Welcome to Sundar's lecture. This is lecture number 80, and in this lecture we are going to see transient responses of RL and RC circuit with the AC and DC inputs. We have seen the manual calculation already in our previous lectures, but today we are just going to see, or we are going to execute the V of t and I of t expressions with the MATLAB Simulink. That is what we are going to see in today's lecture. See, I have just taken all the output equations or the final equations of RL and RC circuit with AC and DC inputs here. I have just consolidated here. See, this is RL with the DC input, this is I of t and this is V of t. This is RC with the DC input, that means transient responses of RC circuit with the DC input. This is V of t expression and I of t expression, as well as RL with the AC, RL with the RC with the AC inputs. I have just written I of t and V of t expressions over here. See, one thing you need to understand here, what is this part? What is this part? Wherever you see this exponential function, and that part will be transient part, and all other parts will be what? It will be the steady state condition, right? At last, what you have to get in RL circuit with the DC input, whatever the current graph should be, whatever the voltage applied to the circuit divided by the resistance value. That is the final steady state condition, right? As well as here you see what will be the final steady state condition here. This value will be vanished and V of t will be 0. Simply you can say that V of t will be 0. As well as you see here, E will be the final value, that means steady state condition, and this part will be what? Transient condition. And here wholly everything will be transient condition, and at last you will get I of t across capacitor. There will not be any current. DC current cannot be passed through a capacitor, but AC current can be passed. Try to understand. That is why I have not written anything here. I of t expression, if you differentiate this with respect to t, and if you multiply with the c, you will get I of t expression. We have seen these kind of things many a times in RLC circuit and RLC DC, RLC AC. All the way we have seen all these kind of expressions and formulas, right? So right, today we try to do these all with MATLAB. First we will go to MATLAB. I will explain one by one, then you can easily understand, right? I am not going to club everything in the same Simulink. I'm just going to explain you RL circuit with the DC input, RC circuit with the DC input, and then RL circuit with the AC, RC circuit with the AC in separate MATLAB Simulink, right? That is why you can easily understand, right? So I will explain you from the beginning. See, I have taken MATLAB, I have just opened the MATLAB. Here you can see Simulink block. Open the Simulink block. I will go step by step anyhow, because if you are seeing this first time my video, you can easily understand, right? So you will get like this, and then in this you can see a blank model. Create a blank model, and you can see the block like this. A window will be opened like this, and in this window what you can do, you just need to save this first. So first save it out. I will go for RC RL with the DC input, with the DC, and this is online class. I have already saved so many things. So RL circuit, transient responses of RL circuit with the DC input, right? That is what we are going to see in this. So here I have just saved this. So double click here. You can see create annotation. There you can take RLC series branch. See, this is the RLC series branch. Click this. You will get a RLC series. Anyhow, 1 minute. RLC series. See, RLC series branch, here it is. You just click this, you will get a blank like this, right? So we need R as well as L here. So I have just taken like this. So double click this one. You can see a branch type. Go there, get R, and give 100 ohms. Any value, no problem. And then you go into this. You just double click this branch, and branch type you make it to L, and in L we are going to take 1 millihenry. maybe you set the initial current to be 0 and you can close this one. Now what we need to do, we have to take a voltage source DC voltage. You just type it out, you can see a DC voltage source here. Click this, you just get this one here. So this value here you make you it as 10, that is up to you, no problem. 10 volt, right? Now this is the circuit and we need to measure current as well as voltage. So you double click here at any place, current measurement. See, you are getting current measurement here, or you type it out fully, current measurement. You just keep this here. It can be connected like this, or you can use the wires to connect like this. Like this also you can connect, no problem, like this. And then we need to see, I will just close this now. That's all. We need to also measure the voltage across the inductor. Now this is the current, right? IL will be same in the series circuit. There is no issues with that. Anyhow, I try to measure the voltage across the inductor too. That is also very important. So for that, you get voltage measurement here. I just got it out. So this is the voltage measurement, and we need to get it across the inductor, right? So this is plus, and this will be the minus. That's all, right? Now we have got both current and voltage. So again, what you need to do, you have to get a block, go to like this, go to, you just get this block, connect this one. So this value will be current, right? So you just make it as current, I block, and then again you just copy this, paste it out, and you just connect these two, you go here and change this tag to V, because there should not be same tags. So this is V, right? Now we have drawn the circuit, and now what we need to do, we need to get the scope. So this is the scope. So in scope, you double click this, go inside the scope, go to file, number of inputs, get it to 2, because we are going to show both the current and voltage. So you have to get like this, then what you do, double click here, get a from block. That will be very easy. From block, connect this one to this point, and this has to be, you just go inside this, click update tags will be updated. You can see current and voltage, I and V, that is what we have given here. So click I, click I, then click OK, then you copy this and paste it out, and just you just connect this one, connect it out. You just go here, go inside, select tag V, you OK. That's all. Now we have drawn the circuit and we have given the values, everything is completed, but we need to get some maybe some tacticals inside the scope. Go inside the scope, click this button, properties button, and you can see a third one, layout, click that, select these two. You can see two different graphs now, and again go here, click this style button, and you can see select white here, select white, and then here you select black, click OK. Now you can see it is very clear, right? Now again what you do, you that's all. Maybe two blocks, this is current and this is the voltage block. That is what we are going to see here. Anyhow, you go here, click this settings, and you just go to display, show legend is there, click that, and then give OK. There will be legends will be available, that will come by after executing the circuit, that we will do now. Now that's all we have done, and you again double click here, we need power GUI, click this one, and here go inside this, double click, get it to discrete and make this value to 1 e power minus 6. That's all. We have done everything now. Now we try to execute the circuit. Click this run button and it will be running now. Stop time we have given it as 10 seconds. So it will be running to 10 seconds. Wait till then. See one thing before that, you change this R value to 2.5 and this L value to 1 Henry. That will, maybe the graph will be very clear to understand. So that is why I have just changed this. You people yourself change the R and L values and you calculate with the manual calculations with the pen and paper and you try to compare that with the MATLAB. But for explaining things, I have just changed this value to 2.5 R value and L value to 1 Henry. So after run this circuit, you can see that you just double click the scope, you can see both values like this, right? This is the current value. What will be the current? What will be the final current? What we have seen here, come here. What is this value? See, I of t will be is equal to E by R minus E by R. This is the transient state and this is the final steady state condition. What is E here? We have taken it to be 10 volt. What is R? We have taken it to be 2.5. 10 by 2.5, what will be the value? It will be 4 amperes. 4 amperes will be stored in the inductor. 4 amperes will be stored in the inductor. See, that is what we are getting here. See here, we are getting 4 amperes of current. It is just exponentially increasing. After some time, maybe after 3 seconds, you see this is seconds, 1, 2, 3, 4, 5, 6 seconds. At 3 seconds, more or less 3 seconds, the current in the inductor becomes 4 amperes. And also the voltage across the inductor is just getting down to 0 from 10 volt, right? We have applied 10 volt and it is just getting down and it will become 0. And that is why we are getting here V of t will be a transient one. Transient. There will not be any steady state condition in voltage across the inductor. Why? Because there will not be any voltage across the inductor after some time. That is the whole idea. You can easily understand, right? Right? You can easily understand with the graph how. See, from here, from this point to this point, it is transient condition period, and this point to whole period will be the steady state condition period. And for voltage, what will be the voltage across the inductor? If it is DC, obviously it is going to become 0. And when it has become 0, after maybe 2 or 2.5 seconds, it is completely become 0. So from this 0 to 2.5, it is transient period. And after 2.5 seconds or maybe more than 2.5 seconds, it is steady state condition. This is how RL circuit works. It is very easy to understand with MATLAB. Try to understand, right? So now what we will do, we try to do RC circuit in the same diagram. Try to understand. I am not going to draw it again because you can double click here, change this L to C, click OK. Maybe you change this value of capacitance to 0.01, then click maybe set initial voltage to be 0, click OK and convert this R value to 100 ohms, click OK. And then what you do now, this is RC circuit, RC series network, right? So what will happen here in RC series, voltage will be E, whatever the voltage you apply, it will be the steady state condition voltage. And then it will be exponentially increasing to 10 volt. And what happens to current here, you see, you can easily see here, what will be the current value? Current value, there is no steady state condition. Obviously, it is going to become 0. Current will become 0 and voltage will become whatever the voltage you are applying here. And what is the voltage you are applying here? It is 10 volt. 10 volt to be stored in the capacitor after some time. That is what we are going to see here. Now you run this one. It is compiling. It is running. Wait until it becomes 100%. See, now it has become 100 here, and then you double click the scope. What is this one? See, this is current measurement. See, this one we are not getting voltage measurement. Anyhow, you go here. see the file type. No, you go to this point, click this, go to display, and you select this display number 2, show grid, enter OK. It will come. Voltage measurement will be shown here. This is voltage measurement and this is now current measurement. Click this one, you will get the values. Anyhow, wait 1 minute, I will show you the things. Yes, you can see now what happens here. The current is going to become 0 after some time, and the voltage across the capacitor is going to become 10 volt. See, this is 10 volt at this time, maybe 5.5 seconds or 6 seconds. At 6 seconds it is completely becomes 10 volt, right? You can easily understand, right? You can easily understand at 6 seconds it is becoming 10 volt, right? And then also, what will be the current? E by R. What is E by R here? We have taken it is 100 ohms and 10 volt. So 10 by 100 it will be 0.1. So it is getting down from 0.1 ampere, it is getting down to 0 after some time. See, capacitors cannot allow DC current to pass through it. Try to understand. It will store, it becomes open circuit. Open circuit means there will not be any current passing through the capacitor, and voltage across the two plates will be 10 volt. That is what we have done here. That is what we have done here. Now it will be very easy to understand what happens in RL circuit and RC circuit with DC input, right? Now what we will do? We will go for AC input. In the same diagram, you just change the DC source to AC source. That is nothing but we are going to do in this diagram. You just change this one to AC. What you do? Just delete this and then double click here. You will get an annotation. Create annotation. There you can see AC source, AC voltage source. Can get like this, and you just connect these 2 points. Maybe you just delete this, connect this one, these 2 points, and then you connect these 2 points. That's all, right? Now maybe you just bring it down. Okay, now we have given AC input here, right? We will first see RC network, and then we will go to the what to say, RL network with the AC input, right? So you can get this values. Once again, you just connect this negative terminal to this point because we have measured the current, right? So you just connect this one to this point, and what you give this AC amplitude to 10 volt and frequency to be 50 hertz. You just click OK and change the R value to 100 ohms and the C value to be 0.01 and set the initial value voltage to be 0 volt, right? Then give OK, and then you just run this one. If you run this after completing the 100%, you can see that in this. Now that's all, it is completed. Now you go to the scope, you can see the graph, right? Like this, it will you will get a graph like this, and you see this is the transient period. See, you just select this one, and you just click like this, and you complete like this. You can see the graph now. Now you see you are getting voltage to be 0.06 here, 0.06 voltage here. That is transient voltage. Try to understand. But what will be the steady state voltage? You try to understand. You just click this and then you click this one. You will get a voltage. You will get a graph like this. And you select this one, this particular thing. You see you are getting 0.03 volt as the steady state voltage. But you can easily see the transient period here. See, it is starting from 0 and it is increased. Voltages are there across the capacitor, and then it is getting down to the steady state condition. Can you understand things right now? Because see, you cannot understand with pen and paper what is the transient period and how it looks like. See, what is the steady state voltage across the capacitor? It has to be 0 point around, you see this is the steady state voltage, it has to be around 0.03 volt. But what you are getting here, around 0.0625 volt you are getting in the transient period. Then it will be reduced. After some time it will become 0. Maybe the transient period becomes 0. See, I will show you that in the expression. See, this is the RC with the AC input. See, this is the V of t expression. And what is this one? This is the transient period. This is the transient period we are getting it in the MATLAB. Try to understand things very clearly, and this will be the steady state condition. Try to apply what are all the voltage. What is Vm here? What is the Vm value we have given here? See, what is Vm? Vm, which is nothing but it will be 10 volt. It will be 10 volt. Vm will be 10 volt, and then its frequency will be 50 hertz. Everything you substitute in this expression. You just substitute R, you know, C, you know, omega, maybe 2 pi f, you know, and then you substitute all the values and T value. You will get the exact value of voltage, whatever the voltage value you are getting in this graph, you will get if you are substituting all the values in that expression. Try to do that by yourself. I am not going to exactly put all the values, and there is no much time available for me to do all those kind of things. I let it to you. You people try to substitute the Vm values and all the frequency values, R values, C values, everything in the expression what we have got in the pen and paper or with the manual calculation in our previous lectures, and then you just cross check with the MATLAB expression, MATLAB output. See, you can easily zoom like this. You can see this one. So I will show you how to get the values. See, just zoom it out, and you can clearly see that. See, at 2.5 you are getting minus 0.03, right? That is the value. And at 2.25, at 2.55, at 2.55 here you are getting the maximum value of 0.035 or 0.0325 voltage, right? That you can just put this value as t is equal to 2.55 seconds in the expression we have got, and then you try to get what is the value we are getting in the manual calculation. That is what you need to do by yourself, right? That you do by yourself. This is the RC and voltage stored in the capacitor. What is the thing we are getting here? Voltage stored in the capacitor. This is the transient period. Up to this point it is the transient period, and then we are getting the steady state period. That is what you need to understand. See, in AC, capacitor will allow the current. DC it becomes 0, but you cannot see a 0 current in the capacitor while you are exciting the capacitor with the AC input. Try to understand. You will never get 0. If it is DC, it will be 0. Try to understand, right? So this is the RC network, and we try to get the RL network now. What we have to do? We have to go here, change this block to inductor, and you give 1 Henry, give OK, and you give this R value as 2.5, and then this L value as 1 Henry, and make the initial current to be 0, and that's all. This is the diagram now. And what you do now? You just run this, wait until it runs now, wait till 100%, and you can see it is completed. Now you click the scope. Yes, you can see the graph now. Click this, and it will be very easy to understand if you click this. See, this is the transient period. See, here, if it is a RL circuit, current will have a transient period, right? That is what we have seen in the expression. See, this is RL with AC input. See, this is the transient part, and this will be the steady state part, right? This will be the steady state part. Try to understand certain things. That is what we have seen. That is what we are seeing here now, and I will show you. See, what is the current value you are getting. 1 minute. You have to be very clear. See, what is the current value you are getting at maybe at 0.05 seconds and all. You are getting it to be 0.06, and then it is 0.06 at this particular time, and it will be reducing. It will be reducing, right? and what is the value you are getting at steady state. See, you click this, you will get a graph like this. This is the steady state, this part. What is the value? It will be 0.03. Double the time the current value is increased at the transient part, right? That is the main area you have to cover if it is a inductor, right? See, the transient part from here to this point, it is the transient part, and after that we are getting the steady state part, right? See, try to understand voltage across the inductor. Here in AC, it will not be a 0 unless if it is DC. If it is a DC, then voltage across the inductor will be 0. Try to understand, if it is AC, you will not get a 0, right? It is we are getting the 10 sine omega t here, 10 positive and 10 negative, right? You can see a sine waveform like this one, right? Whatever the input you are giving, it will be across the inductor, right? That is the whole idea you have to understand, and that is what we have explained things with. Maybe I will go to that particular lecture. Yes, we have just done everything. We have just discussed everything at lecture number 72, basic concepts behind the transient current in RL circuit. I have told you, right? If you put t is equal to 0, what happens to this expression? It will be 0. It will be 0, and then I have told you it will be increasing, the voltage current across the inductor will be high, and then it will be getting down to the normal stage after the steady state condition came. That is what we are getting here. Try to see this graph. I will show you exactly. Yeah, just click this one. See, this is the transient part. We are starting from 0. That is also you have to understand. See this one. You have to see. We are clearly understand that the current in RL circuit, even if it is a AC input, it will start from 0 and it will reach the maximum at the first cycle, first half cycle, and then it will be coming down to the steady state condition. See, that is what we are seeing in the graph, right? So we have seen everything with the MATLAB, and we have just compared it with the manual calculations, manual derivations, and I will let it to you. You people try to understand things and you do by yourself, and you put the manual calculation and compare it with the MATLAB, then it will be very easy to understand. That's all. We have completed everything in transient responses of RLC circuit, and we will start a new topic in the next class. Maybe we will move to the mutual coupled coils, and then we will see everything in the next class, right? Thank you.